Okay, so I am going to take out one test tube representing the body of Ana Garcia. The starting temperature is 37.5 degrees. I'm going to hit start right now. The original temperature is 37.5. The original temperature of the water bath, however, is 3 degrees Celsius. I couldn't get it any lower. In fact, even though I added ice, I added some salt to it, and I was able to drop it from 7 or 8 degrees to 3 degrees, but I wasn't able to get it much lower than that. So this is my starting temperature, time 0. I am now waiting to check my temperature. I will check my temperature every minute. So we are at 32 degrees. Now, when we talk about this, I am looking at my time is going to be my basically my independent variable. My independent variable is the one that it's how often that I am measuring, and it will be represented across my x-axis when I graph it. We're coming up on 56, 7, 8, and I'm going to record the temperature here. I'm going to pull it out. I look at it, and it is at 22 degrees. So I'm going to write that down. It has already dropped from 37 to 22 degrees in the first minute. Now, the temperature is what I am measuring. The temperature is going to go on my graph on the y-axis. It is my dependent variable. It is the one that responds to the changes over time. Therefore, it is my independent variable. It will go up my y-axis when I graph it. I'm going to record this temperature one more time for you, and then I'm going to pause the video because it's probably going to be boring for you to watch. You see what I'm doing? We are at 45, 6, 7. Here we go. If I had a dad joke, I would tell it right now. Maybe I should look some up on break. 6. Okay, so we pull it out. We take a look at it. We are at 13 degrees. 13 degrees here, and I'm going to keep doing this for up to the next 20 minutes or until I get the same temperature 3 times. So I'm done recording the temperature on the first one. The lowest temperature that I got to was 6. I couldn't go any lower. The temperature of the faux anus, that is the diaper lock in the solution, gave heat off to the environment, which happened to be the water bath at 0 degrees. Remember, it started at 3. It actually rose up to 6 degrees. The 2 hit a plateau where they were at equilibrium at 6 degrees. I now have a water bath here at 25 degrees. I am going to take the next test tube representing my faux anus. It is going to be at 37.5 degrees. I am going to start my timer, and I put it in here. I will record the temperature for 1 minute. I'll put the video on pause. You get the idea. I will record the temperature every minute for up to 20 minutes or until I get the same temperature reading 3 times. And this is where I put in my dad joke. So in order to get, just in case you were wondering, in order to get these temperatures just right, I have used, I have used ice bath here that I had to lower the temperature with salt. That is called a colligative property when you add something, a chemical, to the substance to raise or lower the temperature. It's a colligative property, but I could only get it down to 3 degrees. In order to get the hot water, I've got a hot plate right here that I am heating up the water bath. I take a little bit of the hot water, mix it with the cold water to get the temperature that I want. We are at 58, 59, 1 minute, and my temperature here is now at 30 degrees even. So I've gone from 37 to 30 degrees, whereas with the cold water, I went from 37.5 to 22 in my first drop. So this one has changed temperature slower, which relates to my hypothesis. Okay, we are ready for the third and final test. I've got my water here. The water bath is precisely at 50 degrees. I've got my last test tube here in the water bath at 37.5 degrees. I'm going to drop it in there. I'm going to start my timer. My initial time is 0. My initial time is 0. My temperature is 37.5, which is body temperature. I'm going to wait 1 minute, record this. I will put this on pause, but you can trust that I will record this temperature every minute for the next up to 20 minutes or until we get the same temperature 3 times. It's like watching paint dry, watching water boil, watching grass grow. Ten, 9, 8, 7, 6, 5, 4, 3, 2, time. This actually rose to 41 degrees. So the Glaister equation looks at a change in temperature of 1.5 degrees per hour until it reaches the ambient temperature of the surrounding environment. So we started at 37.5. We've gone up. This is at 50 degrees. Now, what we saw with some of these the other ones is that this cold one started at 3 degrees. This temperature came down. They hit equilibrium at 6 degrees and plateaued right there. Here, we started at 37.5 degrees. We went down to 25 degrees, but this temperature didn't change. 37 to 25, there was no real loss of energy into the surrounding environment. In this case, so far what we have seen, and that's 2 minutes, we are at 44 degrees. We're at 44 degrees, so it'll be interesting to see what happens to the water bath if the temperature of the water bath comes down and the temperature of the body, the faux anus, continues to go up, if they'll hit equilibrium just like we did in the other beakers. So I've now finished recording the temperature. I've gotten 3 temperatures at the same amount, which was 44 degrees. So like we saw in the other test tubes and beakers, the temperature of the faux anus, the body temperature, changed and met the surrounding environment's temperature at equilibrium every time. In this case, 37 degrees went up to 44 degrees, and the 50 degrees came down to 44 degrees. Interesting. And it did it very quickly. I thought that this was going too quickly, and I've redone the lab. I had originally done the lab with Ms. Johnson, and we used beakers that were smaller in volume, and I was concerned that we were losing too much of the temperature from our faux anus since it was only halfway submerged. I thought that maybe the top portion was giving off heat to the environment at a rapider rate than would have happened in the solution. But if you take a look at the data that we got when Ms. Johnson and I did it together here, the changes almost match precisely. What's really neat about this is in scientific experiments, you want to perform more than one trial and then average the data. If we were in class, we would take the data from each of the lab stations, put it up on the board, and average that data and then have you graph it. Now we have a second set of data. It's not ideal. It's not 3 sets of data, which is preferred, but it's more than one set of data. We will take that, we will average it and use it.